So the okay, so hopefully you got that stuff in number one. If not, you'll have a chance to get it in a minute. For the second one, actually, some people had an even better answer than I was expecting, because it's technically false.
Like what? So you didn't get the concept?
Not for your, yeah, but you didn't get the
I put
not
false.
because of what you said.
I put false.
I forgot to write one thing in there, which I guess I want to change right now.
Oh, I never greater than one.
I thought you never.
What? Go. What's going on with my computer? Oh, it's frozen. Thought I unfroze. The caveat is that I didn't write any positive number in there. So if you start with a negative number like -1, you multiply it by a number greater than 1 like 5, you get -5. That's actually a smaller number. So if you take a positive number, though, that's what I really meant to put in there until I forgot.
Oh.
Any positive number times 1 is what?
1 itself.
Well, it's the same number, right? So if you multiply any number times 1, it's itself. So if you then increase that number 1, even by a teeny tiny bit, when you multiply them, that will make the other number get bigger as well. So the answer I wanted was true, but because of negative numbers, it would have been false for those of you that use that instance. But if you started with a positive number, some of you did start with a positive number, and then you said that it would still get bigger, or wouldn't get bigger. You said it was false. It's true for a positive number. You take any positive number you want. You can do it in your calculator. Multiply it even with a decimal, like 1.000001.
Okay. 1.
It will get bigger. Always.
0.00010.9. Okay.
Well,
Smart man.
I would, sometimes I show the math on this, but because I want to cover a lot of stuff, I'm not. Now, the opposite is true. If you multiply times a number less than 1,
0,
then it will get smaller. Well, definitely get smaller if it's a positive number. But if you multiply times a number less than 1, it will get smaller. So again, I'm going to give you the short logical version. There's a longer logical version. Take any number, some number, right? Some number times 1, right? Well, it's going to be that same number, whatever that number is. So if I lower this number, then that means this has to get lower. If I raise this number, that means this number has to also get bigger. So that's the simple logic behind it. Multiplying times a number, again, any positive number times a number greater than 1 gets bigger, times a number less than 1 gets smaller. Not this year. Oh, I think 2 years ago, Kiara. She's a junior, I think, yeah. Well, Kiara has 2 Kiras.
Big dog, bro.
2 or 3.
My dog over here.
One Kira is gone, but they still have 2 Kiras. All right, so next, why do you put money into a bank or in stocks? Why? How?
Because you're either saving, so you're keeping the same amount.
Oh, yeah, and
adding
it
on to it. And
Somebody else put something about credit.
You're adding on to it, or like stocks.
What is that stuff called that you want? Like, obviously, if you put it aside and you don't spend it, you'll be saving it, but there's something that you want that's called something.
You want more money.
How do you get more money?
Taxes.
Getting a job.
No, the tax is what you pay.
But you get it back.
There's something that you get that's,
Crypto?
what's that? No. I don't trust crypto. So there's something that you get for letting them keep your money.
More money.
Alone.
But why do they give you? Well, there's a name for what they give you.
Alone.
Bank residence.
No. Nobody knows this word.
Wait, what's the first one?
Yeah.
Huh? Yeah, you've heard this one, guaranteed.
What's the first one?
You know it?
I.
You know it?
Oh, that's why I'm not influencer.
Oh, wait,
Does start with IN.
Oh, no, that was
Interest. Look at that. So you get interest. Like the bank literally says, now I will say they don't give you very much right now. The bank literally says, I'm going to give you more money for letting me keep your money. Why do they do that? Why in the world would somebody just give you money?
Why not? They're not getting scammed.
Yeah.
Why you go?
It sounds like a scam, doesn't it? Like, why would they give me money? What's going on?
They're keeping your money.
No.
So, big deal.
They keep your money.
So
You
you
give
get
it to
it
someone else.
back at the end.
You gotta pay it back.
Nope.
Because it's interest.
You do not pay interest back.
They
Not,
give you
not on the
anyway.
money
They
they're
take your money,
keeping
there's
for you.
money else.
You pay interest if you borrow money, which is
So
kind
Do
of
they
a
keep
kicker.
your money just in case you get in debt?
No, that's not why they're keeping your money. There's a reason why they want your money.
So you can stay with them?
Yeah, well, I mean, yeah, they want you to stay, but they want you to stay because they want you to put more money there.
Don't go to Wells Fargo and cheat.
Why would they do that? Why would they just give you
I
money?
ain't gonna pick up America.
They don't give you as much right now as they have at times, but they still give you interest. Savings accounts.
What,
typically
wait,
some
yeah,
checking.
don't
So
they
you
give you
get
the
scam.
invest into something?
Shut up!
Nope, he's answering the question. Why are you telling me?
We're being respectful today. Go
So,
ahead, man.
why would they do that? Let me ask you a question. How many people want to buy a car pretty soon?
I'm getting one.
Or yeah, like by soon, I mean like in a few years.
Oh,
You
not
want to buy a
right
car,
next
right?
year. I'm getting one this
Let's
year.
say a car costs $15,000. You have $15,000?
Yeah.
Oh, no, maybe I do.
Do you?
Yes,
You have
No,
$15,000 right now.
yes, in my bank account.
Wow.
Show me. No, show Dante.
I want you to stay in right now.
That's what I'm getting, that's what I'm getting a car.
Give me a couple
I'm
minutes.
getting- I might get a dog.
So, here's the premise. Typically, people don't have enough money to buy a car, certainly not to buy a house.
So they give you more.
Right, now it's mine. So, you typically can't just walk in and say, I'm gonna buy that car, here's the money for that car. Not like you go into a store and you buy
We
groceries.
gotta put the light on.
You certainly don't walk up and say,
Gabby, bro, shut
What's it
up.
called?
you're about to be out there.
My bad.
So, you certainly don't walk up and say, well, very few people, I'm gonna buy that house, here's the money for that house, thank you very much, we're done. What you do is you borrow. Here's why a bank gives you interest. Because let's say Nick wants to buy a house, let's say Gabby's putting money into a bank, they say, Gabby, we're gonna give you some interest on your money. I'll give you a number of like 1%, it's not very much. They take Gabby's money, she said, oh, that's great, here's my money, hold it, pay me money at the end of the year. Nick says, I need to buy a house. I need to borrow money, so he goes to that same bank. They're gonna charge him 3%, actually probably more than that. Using Gabby's money, it's not their money. They just give him Gabby's money and say, here's the money. So he's paying them more than they're paying her. That's how they make money. But they do have to actually have that money. They can't just say, make up money out of nowhere and say, oh, okay, well, we'll imaginary, like, just give you some money. I mean, they gotta have the money from somewhere. So they get people to deposit money. They pay them a little bit extra, but then they charge people more money than that when they loan the money out. That's how a bank makes money.
What if it
And that's a
does
simple
them,
one.
and then we can make them lower the price because we know what they're doing, so that working out.
It all depends on how competitive the market is. It's like right now, most banks aren't paying you a whole lot to put their money because they got tons of money. Because most people aren't borrowing money. If a lot of people are borrowing money, and so the banks need money, then they'll pay you more money to put money with them. It all depends on like tons of factors. Like that's a very simplified version. So again, quick question.
So what's it called when you go to the bank unless you get a loan? I don't know, but like.
Don't you gotta pay that?
Well, I mean, there's a
Yeah.
you pay back the money you borrowed plus an additional amount.
They give it an envelope, they had money in it.
It's called a loan.
Oh, yeah.
What's the word I said? My God.
If you're borrowing it, it's called a loan. Oh, I know what you're talking about.
Oh, like, they take money out their account.
Yeah, I know what you're talking about. Like you can get a, it's still basically a loan, but
Apparently this guy.
they're gonna take the money out of your paycheck or something when you get paid or something like that. So here's the next step to that. This is the one that could change your life, like literally could change your life. Growth, we already kind of talked about. Growth means like you're getting bigger. Decay just means it's getting small. That was when I said you multiply by a number smaller than 1. That means something is going to get smaller. So the value is going to decay when it gets smaller. If you've ever heard of tooth decay, it literally means your teeth are getting smaller because they're dissolving. So here's the thing that we're going to go over and how this will change your life potentially. Oh, it's not really up yet. All right, we'll do this other thing real quick. This is real. I'm about to tell you something. Like, I'm not even joking. It could change your life. Like, if you truly can do this, now not very many people would be able to stick with it, but if you could truly do this, it would change your life. The next thing we do, not this. So, You guys know what viral means, like a video goes viral, right?
Yeah.
Like it means that it's gotten a whole lot of views in a very short period of time. It means the growth rate accelerated, like it went really, really fast. It blew up. I'm gonna ask you a question. I want you to throw out some answers. So we start with so literally that word viral came from viruses. So we start with a 1-cell virus. It literally has 1 cell. That's it. 1 cell. Every hour it doubles. So after an hour it's 2 cells. After 2 hours it's 4 cells. How many cells after just 1 day would it be? Take a guess.
1.
No.
Yo,
Doubles.
yo.
It's already after an hour. It's already 2.
48?
28? Is that what you said? 48 or 28? 48. Throw another one out. Just say some numbers. Like, think about it.
No, 100, 100.
100. Throw another one out.
Every
Every hour it doubles.
it'd be like
So 20,000. That's a big number.
Okay.
Yeah,
I thought
Yeah, it gotta be
I
48. It gotta be 48. Every hour.
But
But it depends how many hours you work.
24. I said
24 hours?
1 day.
I said I thought.
So after 1 day, doubles every hour.
And that was already up.
period. I'd say the first.
A million?
It's 48.
Oh, somebody said 1 million. Wow.
Wait,
That's aggressive.
24 hours- Isn't it 24 hours all in one day?
No, it doubles.
Well, like every hour it doubles, and you're gonna. We just can say after 1 day. Where would it be?
I don't even know how many hours.
Grant, you stay back. Don't try to be funny.
All right. All right.
Don't
Come
make
on.
that be-
Anybody else? Quick. Anybody else? Going once? Going twice?
So.
All right. So let's see. 96. Kind of close to 100. So here's the concept. After 1 hour, right?
No, it was.
That was this movie.
All right. After 1 hour, actually, let's do it this way. I'm not going to draw a picture. You get the concept. It's 1, then it's 2, then it's 4, then it's 8. Like I'm not going to draw the pictures out of all the cells. So I'm just going to write the numbers. So after 1 hour, it's 2 cells. After 2 hours, it's 4 cells. After 3 hours, it's 8 cells. After 4 hours, it's 16. Anything look familiar?
Okay.
Exponential function.
We're multiplying by 2, right?
No, that's not.
It's
Look,
There is.
2,
There
8.
is.
Where does 6 at?
What's 4 times 2, Gabby?
We're multiplying. The pattern is multiplication.
Oh, yeah.
So this is an exponential function, right?
It's just 84.
What was the formula for exponential function?
F of x equals a times b.
Well, not squared to the x power, right? What's our b value?
The constant.
The pattern.
What is it in this?
2.
It's times 2, right?
Period.
So we're not even gonna count that because we started at 1 cell, so that doesn't even matter. So we have 2 raised to what power? What's the x?
2. It's 2 squared.
Nope.
1.
2 is the pattern. You can't use 2 as the x. Nope.
5.
Nope.
I thought you said it's always the first thing.
One. Negative 2.
Nope. How many hours are we going for?
24.
Bam. That's 24. So this is an exponential pattern. Now let's figure it out. You can't really do it on your, I mean, you could take you a long time. So I'm going to give you a shortcut. So this is 2 raised to the 24th power, 16,777,216.
So what
You
is
can
the
do it on your own when you get a better calculator.
Just let the virus take you.
16 million after
So
only
what is the
24.
million? I guess they was close.
Well, actually, they weren't even that close, and they were by far the highest guess. That's why
Thank you, Gabby.
viral is used, is because the rate it grows at is exponential. And I told you when you start dealing with exponents, numbers get really big, really fast.
And I don't
Saying
like that.
goodbye
It's
to your
never-
love.
So I'm going to give you 2 real life things that if you follow these, it literally could change your life.
Okay.
When I was in sales, why do we have to comment after everything I say in this class? One of them.
I didn't even say
Oh,
nothing.
but you have been up until I told you you're going to be outside.
I didn't say nothing. It
You
wasn't
were.
me talking.
You were.
What did I say?
You were.
Gabby, just.
See, right? You're still doing it.
I didn't even say that.
Talking about. You can't just let somebody else have the last word.
I didn't
Most
even
of you.
say that.
See? Do this. I'm going to say something. Don't say it. Just let's see if you can do it. Let's see. All right. So if you want to go into business for yourself, all right, which some of you might, like some of you might say, hey, look, working for somebody is not really for me. You're going to need clients, like you're going to have to sell stuff. So the model that you want is an exponential growth model. Instead of giving like a discount on one item, or instead of, what would the word, like, I mean, you do want to work hard to get clients, obviously. This is what gyms do, by the way. If you've ever like seen in a gym how they say, hey, if you bring us a client, we'll give you like $5 off your membership this month or whatever it is. That's what they're doing. They're trying to do an exponential growth model. So if we take an individual and he starts with 20 clients, I'm going to zoom in. He starts with 20 clients and he's just adding, it's Isaiah, he's just adding, actually he starts with 10, he's adding 20 every week.
Why did it say it starts with 20?
Yeah, I changed it over there because that matched up with I had already done the table at the bottom. So let's change that. So he starts with 10 and then he adds 20 every week. Oh no. There. Keisha's going to start with one client. That's it. But every week her clients, first week it'll only be one client, but every week after that, they're going to give her one client. So basically she's doubling her client base. If she starts with 1, next week she'll have 2. If she has 2, next week she'll have 4 because each one of those is giving her 1. So she'll get 2 more. So she's doubling, kind of like we just did with the virus. So just to show you, I was going to go through a long thing with this and have you guess again, but we're going to just go ahead and show. After 2 weeks, she's only at 4 and he's at 50 because he's added 20 both weeks. So still pretty high above her. When you get to only 2 months would be basically 8 weeks, she's already significantly above. That is without a doubt the way every company should want to do business. If you go into business for yourself, have some kind of program where you do that with clients, like where your clients bring you clients. That's what we did in sales. Like that's the way that all good salespeople work. You didn't want to have to bust your butt for the rest of your life trying to go out and bring the clients in. You could get your clients to give you the clients, make your job way, way easier, and you're a lot more productive.
Did you do that this year?
Every good salesperson did that, yeah. So I mean, of course. Yeah. Well, then if you go into business for yourself, that's all you're ever going to hear is it's all about getting clients. All right, so yeah, we'll go ahead and move on. So anyway, here's what we're doing today. We're going to do exponential growth. So that's your title right there. So write that down. That's the formula for it over there. Write that down. I mean, we've already done exponential functions, so this is just an extension of that. Oh, really? We're just talking specifically about a growth rate now, as opposed to just the formula that we learned. So a growth rate, so here's another definition you need. The growth rate is typically a percentage. So like, for example, when you save money, I just told you they might give you an interest of 1%. That's your growth rate, 1%. They're giving you 1% as an interest rate.
What did you say the definition was for growth rate again?
It's like the percentage rate that your money is growing at. Like if they're giving you an interest rate of 1%, that's your growth rate. You would change it to a decimal, which we're going to talk about in a minute. So here's the other part that will, well, this one and then what we do tomorrow for you guys. So here's what you can do. If you get jobs, a lot of you will live at home, certainly until you're 18, maybe beyond that. You won't really have a whole lot of bills. I mean, shouldn't. If you're living at home, I don't really know what bills you're gonna have. You may have to pay for your own car and stuff when you get that.
Yeah, that's it.
But hopefully you are able to put some money aside. Again, you do that for
A year?
well, you'll be there longer than a year. I mean, do it for 10 years. Like if you're on your own, if you have to move out, things could change. But if you're living at home, and you put money aside, quick math, living at home, there's 52 weeks in a year, right? Actually, we'll round it to 50 weeks in a year. So let's say you put aside 20, I'm just throwing numbers out. You put aside $20 a week, right? That's $1,000. So $1,000 a year. And then you do that for as many years as you can. I mean, I'd always try to put away. I mean, $20 a week. Some of you spend that in crap out of vending machines here.
I do.
And especially if you then go to Dunkin' Donuts and Starbucks and all the other cups that I see come in here. So let's say you save up. We're going to do different numbers on this, but let's start out with $10,000. So let's say you're able to save up $10,000. Again, most people can't say they're going to spend it, but you can save. I've got kids that I hope do this that I've taught this lesson to. This is the value, the initial value. So when it comes to the model, this is the A value. So A, remember how we said A was an initial amount?
That's
Remember that? A is the initial amount in this form. So you need to make notes. That's your initial amount. It's still your y-intercept, but we're not really graphing this, so we think of it more as the initial amount. That's how much I'm going to invest. That $10,000 would be my initial amount. Now, the higher that number is, obviously, the better off you'd be on this model. But let's say 10,000. We're going to do, you're going to
So
actually do
8 is basically the 1,000.
Well, remember, this is the same formula we did before. A times the one we just did a minute ago. It's the same formula. All we're doing is we're breaking this down into 1 plus R. So the 1 plus R is actually your B.
R is B.
Well, no, the 1 plus R is B.
And the exercise house.
And X is still X. X is how many times you're doing it for. Like we just said 24 was our X in the other problem because we were doing it for 24 hours. Now it's going to be the number of years we do it for. Like how long we leave our money in this, we're going to put it in the stock market.
Skill, so how do you know? Wouldn't it be 50?
Well, no, we're not investing it. That's just saving the money. That's $20. This is actually linear. We're just saving $20 every week. We're not getting any exponential growth yet. We will get exponential growth on this though. So that's where we're going to start using the model. So here's what you do. Let's say in 10 years, you're 25, right? Approximately. Some of you might be 24, some might be 26, but let's say 25. Retirement age, does anybody know what retirement age is? Like typically?
It's
60, 50.
65 normally.
Yeah.
Normally it's 65. So that's 40 years you're going to leave your money in the stock market. Now, you can lose money in the stock market. Like there's no guarantee that you make this, but I will tell you there's no 10-year period where the stock market hasn't done at least 10%, gained at least a 10% rate. So we're going to use for our rate, our R, that's our growth rate. We're going to use 10%. There's no period for the stock market where, yeah, you pick any 10 years. You could pick 1992 to 2002. You could pick 1998 to 2008. Like you pick any 10-year period and the stock market gained at least 10%, sometimes more. So that's why we're using 10%. Actually comes from if you remember how we did line of best fit through data? It actually comes through that. The line of best fit would have a slope of 10, a 10% slope. So here's our formula. What's our initial value?
10,000.
10,000, right? We said that was our A. So that's what we're investing, $10,000. What's our B value? That one's a little trickier. What did we say B was right there? Well, B is not, R is 10%. What's the B pointing to?
20.
Nope.
Is it 1 plus 10%?
It's 1 plus 10%. So we got to convert the 10% into a decimal. So 10% is 0.10. So I'm basically saying 1 plus 0.1 is the B. And then I'm going to raise that to X. What is the X?
50.
That 10?
What's that? Nope. 10, this is the 10%. 10% we converted to a decimal. You have to make it a decimal. You can't use 10% as a
Oh, okay.
number. You gotta have a number. You have to have a decimal you can add to that one, basically.
20.
What did I say? You're starting at 25 and going to 65. We're doing this, yeah, it's 40 years. It's every year we're saying it, what it's called compounding interest. We're gonna go over this in more detail when we have this class. So if you were able to leave, oh, I don't know why I wrote X. If you were able to put $10,000, and again, that's not even that much money if you really truly saved and you didn't spend it. Because that's only $20 a week. Some of you that have a job, you're gonna have you have no bills. You should be able to save way more than $20 a week if you really, really wanted to do this. What do you think? How much money are you gonna have after 40 years? What would be in there? How much do you think? Let's take some guesses. 15,000. What else? So you start with 10,000. What else? Any other guesses?
What was the question?
So you started with 10,000. You put it all in there at once. You just leave it for 40 years. And we're going to say it gains 10% every year. What do you think? 15,000 was a guess?
25,000.
What did we spend?
You said what? 40,000.
Just makes sense.
I can't even see my calculator to know what it actually is.
Just to get 25,000.
17,000.
17,000? You already said 15.
I said 25,000. Shut up. But I said I had
25. Any other guesses? 400,000. Somebody just said, I'm just going to go high because I know it's supposed to be a high number, right? Is that right?
Yeah, when you pull the calculator out, I was like, yeah, it's probably good.
Any other guesses? So you think from $10,000 we're going to have $400,000?
I think it's the second. Over 40
I
years.
think it's 17,000.
I think the second one or the third one.
That's the second.
Perfectly the third one because I put it.
I bet that.
More than 400. $450,000 from 10,000.
It was close, it was just close.
Oh.
It's the second one.
But still, my math is not adding up. How would you do that?
You can't do it on your calculator. Well, you could, but it'd take you a long time.
Oh, well, so.
You'd have to take 1.1 and multiply 1.1 times itself 40 times. Then multiply that times 10,000.
That takes way too much.
So that's why I did it on this.
On the average, is it more than?
I don't know what the highest gains were for a 10-year period or what the lowest, but I know, well, actually, I haven't even, to tell you the truth, I have not researched it, but what I read before about the stock market is that for any 10-year period, it's never gained less than 10%. If it gains more than that, then great. But the point is, this is what exponential growth does. If you want to change your life, save some money early, put it in there and forget about it. If you do 15,000, I think it's like $700,000. So only another 500 or 5,000 gets you, I think, almost 700,000. And then if you do, I think to get over $1 million, I think you had to do 20,000.
Well, that's not bad.
That's a little too much math for my life.
So let's see, 1.1 raised to the 40 is that times 20, 1, 2, 3. 20,000 gets you almost $1 million, not quite $1 million. So,
That's retirement.
again, if you can do this, if you can put money, if you are a saver, now again, there's no guarantee in the stock market. You can put money in and you could lose money. But if you're leaving it in for 40 years and you lose money, then our economy has much bigger problems and we've probably gone to war. We've been taken over by aliens and nothing's gonna matter then.
Bro, aliens are.
Actually, war is not even bad for the economy. War is pretty good for the economy.
What?
Creates jobs. All of a sudden we gotta build all kind of military stuff, and wars typically wind up eventually being good for the economy. So that's what growth is. We have a formula. Here's what I want you to do. I've already done 10,000. Well, you're gonna do it. It's just a matter of whether you do it next class or today.
Please
Next
don't
class.
make us do it.
Next class.
Please don't.
Alright, because you'd have to get another calculator anyway. That's the only thing that saved you. But
Oh, let's bring it.
so next class we will do that.
In the
Oh, wait,
packet.
we get out later today. We got 9:05. We got 6 more minutes.
Yeah.
All right, we got to do something else then.
The packet.
Okay,
Put it
let's
in the
play
packet.
Duck Duck Goose.
No, that's not math.
Um,
Let's see.
Yeah. Yeah, you gotta find the probability of that person chasing.
So just shut
back to
up.
the
Oh my
phone.
God.
You gotta put your comp.
You know, you never shut up. Always talking.
This is what you were gonna do, but that's for a full period, I think. All right, here's the next thing we're gonna talk about. So this is decay. So here, I'll just make you write it down. Here's the formula. So write down exponential decay. We'll just take the note and then you already have it written down for next class. That's all we'll do. We won't do any actual math with it. So when we talk about decay, I'm assuming you know this, but maybe you don't. And again, this will be our real life thing tomorrow. Again, can change your life. Because I guarantee you half the adults out there don't understand what we're going to do tomorrow. So I'm about to write the formula. So right now you're just writing exponential decay. When you buy almost anything, a car is the example we'll use tomorrow, it doesn't keep its value. So you may buy a $10,000 car, a $15,000 car. It's not worth $10,000, like literally, as soon as you drive it off the lot, it's not worth $10,000 anymore. The value of that goes down. And the value that goes down in an exponential way. Like if you remember one time we had a curved line that went up like that, that's exponential. Oh, here, write this. That's exponential growth. So draw a little graph, like you could draw a little graph like that. That's exponential growth. The value is going up as it goes, as the x values increase. This is exponential decay. The values are going down as it goes, as the x values increase. So this is exponential decay. This is exponential growth. You do need to know how to do that. And then I'll write the formula up and we'll be done. Who is that out there? Is that Joe again?
It's Jill. I didn't see.
Yeah, it sounded like Joe just trying to open the door.
Wait, let me.
So here's the formula for this. I'm going to get out of the way and then you can just get all of it out. So it's kind of the same formula, except it's 1 subtract r. Because remember, if we multiply by a number less than 1, then our original number goes down. If it's greater than 1, then it goes up. So write down the quick graph for decay, write down the quick graph for growth, write down the formula for decay, and then we're done.
What time we get out of here?
9:05, so 3 minutes.
When, let's just say.
Wait, this is
And then start saving your money and invest it, and leave it in there.
And I'm gonna invest it, I'm gonna lose a
Yeah,
couple.
that right above it.
$100.
Well, almost nobody can actually leave money somewhere without spending it, so I doubt very many people do it. But if you do, I mean, it will change
I
life.
can save.
Instead of working until you're 80 or 85, you can actually retire. And then enjoy the rest of your life.
It's a good, do you have an extra folder with this?
Blue and red, right there.
Thank you.
Oh.
I put in action that should be. But she's her own place up.
Bro, it's a song.
Oh, no, that's that boy.
Boy, in this class?
The one who just came. Can I use one of your Sharpies?
Oh, awesome.